Hello to you watching this video. So in today's video, we will be solving for the reduction of live loads as per NSCP 2015 provisions. So suppose that the given second floor structural framing plan, so this is that plan, will be used for a two-story residential dwelling. We will be assuming that the total dead load pressure at the roof beams is 1.1 kilopascals and the total dead load pressure at the floor beams is 4.5 kilopascals. If the roof beams have the same layout with the given structural framing plan, which is this, we would be determining the live load pressure to be used in the design for the following beams and columns, or column I should say. So we would be solving for the live load pressure that we will be using for beam GH, which is this beam DE, which is this beam, and column E, which is this particular column, assuming that column E, or the column E that we will be analyzing, is the column at the first floor. So after which, we will be using and comparing the result of NSCP 2015 and UBC 1997 because they would have inconsistencies in between them. So first things first, let us solve for the live load that we will be using for beam GH. So again, beam GH is this particular beam at the bottom part. So the first thing that we will be doing is for us to know the unreduced live load that we could apply to the structure. And once again, in this particular video or in this particular setting here, this will be used as a residential dwelling, and from that we would be going to this particular table in order for us to know. So with that, guys, again, residential dwelling, so we would be making use of we would be making use of this particular table here since this is for residential building, and let us assume that it is considered as a basic floor area. So again, from that we will now be making use of 1.9 kilopascal as seen at this table here. So again, for the unreduced live load that we will be using, let us write it as LO, or the unreduced live load. So again, that is 1.9 kilopascal. Okay, so let us now check if we could reduce this live load by getting the tributary area of that particular beam. So again, we are to consider beam GH. Again, this here is beam GH. So what is tributary area in the first place? When we say tributary area, that is the area of responsibility of that particular structural member. And in this slab here, so in this particular slab, let us know if it is a one-way slab or two-way slab in order for us to know its tributary area. So one way to know its behavior, if it is either one-way or two-way, is by getting the ratio. So let us solve for the ratio of the short span over the long span of that particular slab. So as you can see that the short span here, this measurement is 3.5 meters. So 3.5 meters. And we would be dividing this by the long span, which is 8 meters. And from that, guys, so 8 meters. And let us solve for that particular ratio. So that is 3.5 all over 8.5. I mean 8, I should say. So that's now equal to 0.4375. And as you can see that it is less than 0.5. With that being said, guys, this is considered as a one-way slab or one-way distribution. Okay, so from that, guys, it is now assumed that for this particular slab here, so in this particular slab, the distribution is only on one dimension. So the loads will only go through the or to the longer span. So as you can see here that the loads at the slab will not be transferred to this location. Okay. So with that being said, guys, for beam GH, its tributary area will be this shaded part right here, which is half of 3.5. Okay. And from that, guys, it would now look like this. So let me erase this. So again, since this is a one-way distribution or one-way slab, its tributary area is this shaded area here. Again, this is half of 3.5 meters and that is 1.75 meters. And again, the long span is 8 meters. So in order for us to solve for the tributary area is the area of this shaded part, which is 8 meters times 1.75. Okay, so using the calculator below me, 8 times 1.75, sorry, the tributary area is 14 square meters. Okay, so with that being said, if you would be going back to the NSCP code provision, it is stated here that reduction of live loads may be live loads may be reduced on any member supporting more than 15 square meters. Okay, and since the area that we have solved for is less than 15 square meters, that means that we would not, or we, as per NSCP 2015, we could not reduce the live load. Okay, and from that, guys, the live load that we will be using for this particular beam, which is beam GH, that is basically 100% of 1.9 kilopascals. Okay, so 1.9 kilopascals. This is now the live load that we will be using. Okay, so proceeding, for the next problem here, we are now to determine the live load that we will be using for beam DE. Okay, so for beam DE, it is that this particular beam here. So I am highlighting it in yellow. Okay, so for that beam, we would now first, or we should first solve for its tributary area. And for its tributary area, guys, again, it is the area of responsibility in Tagalog, in Filipino. Yung area na yun, yung bubuhatin ng beam yun. Nyo, I should say, or in this case, yung beam DE. So as you can see that this beam D is supporting an area of this slab and also an area at this bottom part. And earlier we have already indicated, or we have already solved for the ratio of this slab. And from the ratio, we figured out that the tributary area, or sorry, the slab below it, this slab here, will undergo one-way distribution. So again, from that, guys, this is now the tributary area of beam DE at this slab. Okay, again, one-way distribution. So what about for this upper part? So if ever that this beam is just one way, or by its ratio it is a one-way slab, it means that this is now its tributary area. Okay, so this is now, this should be the tributary area if and only if it is a one-way slab. But before assuming, let us first solve if it really is a one-way slab. Okay, so again, the ratio, or the in order for us to know, we must get the ratio of the shorter span over the longer span. If ever that it is less than 0.5, this must be one way. Okay, and if let's say this this ratio is greater than or equal to 0.5, that means this is two-way. Okay, so substituting known values, as you can see here, this is 8 meters and this here is 4.5 meters. So the shorter side there is 4.5. So from that, 4.5 meters divided by the longer span of 8 meters. This is now equal to, so looking at the calculator below me once again, so 4.5 all over 8. So the ratio here is 0.5625. And as you can see that it is greater than or equal to 0.5, thus it is two-way. So since it is two-way, it will not transfer it in a one-way distribution. So self-explanatory. So when we say two-way, it will now transfer all of the loads in two directions. So that is vertical direction and horizontal direction. So in order for us to know, from the corners, we will be drawing a 45-degree line. So suppose that this is that 45-degree line, assuming that my drawing is correct, which is not, by the way. So if you would be drawing 45-degree lines here, so for that triangle that we did, so we would now be, that is now the tributary area of the beams along the shorter spans. And from that, guys, ito na po yung kanyang tributary area. So, as for the rest, ito pong location na to. So, as you can see that we have formed a trapezoidal shape. So, the trapezoidal shape will now be transferred about the longer side. So, this is now the tributary area. Okay? So, let me get this out of the way first. So, let me erase everything. Okay? So, in order for us to have a better figure here, let us just shade it via this trapezoidal shape. So, this is now the tributary area that we will be using for um, beam DE. So, we have here the rectangle at the bottom part. So, let us um, name this as A1 and let us name the upper part as A2. So for A1 or area 1, that is basically 1.75 times 8 meters. So again, that is, so I actually forgot the answer there. So 1.75 times 8, so that is 14 square meters. And as for the area at the top, as you can see that this is a trapezoid. So for the area of a trapezoid, so area of a trapezoid, that is basically the average of both lengths. So let us say that this is length 1 and this is length 2. We will be getting those averages, or the average of both, I should say. So L1 plus L2 all over 2 times the height. So the height of the trapezoid in this scenario, that is 4.5 meters all over 2. And that is equal to 2.25. Okay, so this is 4.5 meters. Okay, so times h of this side. So we already know the value of L2, that is 8 meters. But what about the value for L1? Take note, guys, that this angle here is 45 degrees. And this angle here is also 45 degrees. And from virtue of SOHCAHTOA, whatever this length is, so again, let me just, let's say, go to this part, which I will erase later. So again, if this is the trapezoid, and if this here is 45 degrees, and this is also 45 degrees, whatever length this is, that is exactly equal to this length right here. Okay? Again, maybe it would be better if I would be explaining it this way. If you would be having a 45-degree triangle, so assuming that this is a 45-degree triangle, if this is the hypotenuse, and let's say that this is the x, or this is side x, and this is side y, I should say, and this is side x is exactly equal to y. If and only if it is 45 degrees. So you could actually prove it via trigonometry or from the principles of SOHCAHTOA. But I would not do that here in order for the video not to get any longer. Okay, anyway, so again, with that being said, whatever the length here is, that is also this particular length. So from that, if this is 2.25 meters, we could also say that, let me erase this first. So we could also say that this here is also 2.25 meters. And this here is also 2.25 meters. So from that, the value for L1 is equal to L2, which is 8 meters, minus 2.25 meters times 2. Okay? So we have two sets of 2.25 meters. And from that, we could now say that the value for L1 is equal to, so 8 minus 2.25 times 2. So L1 is now equal to 3.5 meters. Okay? So solving for solving for A2, or the area of the trapezoid. So the area of the trapezoid is equal to 3.5 meters plus, so that is L1, 3.5 meters, plus L2 of 8 meters divided by 2 times the height of the trapezoid, which is 2.25. So the answer here would now be equal to, so 3.5 plus 8 divided by 2 times 2.25. So the answer here is 12.9375 square meters. Okay, so let me double check using my calculator. So 3.5 meters plus 8 divided by 2 times 2.25. 12.9375. Okay. So, in total, the tributary area of that beam is equal to, again, the sum of both areas. So, substituting known values, that is 14 plus 12.9375. And with such, the tributary area is now equal to, so 14 plus 12.9375. That is 26.9375 square meters. Okay, so take note that this is now the tributary area of this trapezoid here. Okay, so let me just erase everything. So again, the tributary area is 26.9375 square meters. So let me check, 26.9375. Okay. Oops, sorry. Anyway, so since this area is greater than 15 square meters, and since the live load that we will be using for the floor area, so the unreduced live load that is equal to 1.9 kilopascal, since this live load is less than 4.8 kilopascals, and its tributary area is greater than 15 square meters, it means that we could actually reduce this particular live load. Okay? And as per the formula, according to NSCP, the reduction of live load is equal to R times the tributary area minus 15 square meters, where R is equal to 0.08, which just want to disclaim, if we would be making use of UBC provisions, that is not the case. Doon po sila nagkaiba actually. And I'm not saying that the one for NSCP is wrong, but if you would be comparing both, medyo mas maniniwala ka sa UBC actually. Okay, so later on that. So substituting all known values, so R is equal to 0.08 times the area of 26.9375 minus 15. So this is now the reduction that we could apply. So from that, this is 0.08 times 26.9375 minus 15. So this is now equal to 0.955. Okay, so take note that this answer here is 0.955%, not 95%. So 0.955 meaning that it is actually below 1%. Okay, so before applying this factor to the live load, we must first check if it is within the allowable range. So looking at this area here, so these are our max, or the maximum reduction that we could use. So it is either of the following. So let us compare 40 and 60 first. So which one of this will we be using? So 40% for members receiving load from one floor only, and 60% for other members. So as you can see that this particular beam here only carries loads from the second floor, not the roof deck, not the first floor, only for the second floor, meaning that the maximum R, or the maximum value for the reduction, is 40%. Okay? But aside from that, we also have this formula here, which is 23.1 plus 1, times 1 plus D all over L. And for this value for D, that is the dead load pressure, and L is the live load pressure. Okay, so as you can see here that the dead load at the floor is 4.5 kilopascal. So this was given earlier in the problem. So I would not write this solution any longer. Rather, I would just input them directly to our calculator. So again, that is 23.1 times 1 plus D all over L. Again, the dead load at the second floor is 4.5. So plus 4.5 divided by the pressure for live load. As you can see that according to NSCP, that is 1.9 kilopascal. So from that, guys, the answer here is 77.81. Okay. So, oops, sorry. So from that, 77.81, so from that, we will be choosing between these two, which is the lesser value, or if you are getting confused, both of these factors should be satisfied, or both of those reduction rates should be satisfied. And from that, guys, if both of them should be satisfied, it would be better if you would be choosing the lower value, so that if this value is less than this value, automatic naman na mas mababa na din siya dun sa mas mataas na value, di ba? So as you can see, guys, that since our solved value is greater or is less than 77.81, and it is also less than 40%, we would now be making use of this reduction. Okay? So in order for us to know the reduced live load, that is L, that is now equal to, so since this here is the reduction, yan po yung aalisin natin, or in other words, that is basically the discount, or in other words, that is 0.955% off. So with that, our solution would be the unreduced live load times 1 minus 0.955 all over 100, or 0.955% off from 100%. Okay? So with that, this is now equal to 1.9 times 1 minus 0.955 all over 100 times, oh, by the way, that is to be it. So the live load that we will be using here is equal to, so 1.9 times 1 minus 0.955 all over 100. So the answer here is very close to 1.9. That is 1.88. Okay? So if you are wondering, bakit ang liit ng reduction rate? So that is actually the inconsistency between NSCP and UBC. Okay? So if you are wondering, no, parang ang layo naman ng area mo, that is 26.9375. Ang layo niya sa 15 square meters, pero bakit yung reduction niya 1.88 lang? So, disclaimer, wala pong mali sa solution. All of these are correct, and once again, I want to emphasize that this is really 0.955%. Okay? So, again, stay tuned po for the next video, or you would be comparing our result here to the next video, kasi yung next video, which is the UBC provision, which is very similar to this provisions, medyo may unit inconsistency lang, kaya po yung answers natin mamaya malayo. Pero regardless, before we proceed to the next video, let us first solve for the live load that we will be using for column E, using NSCP provisions only. So for column E, that is this particular column here, we would be solving for its tributary area. So for its tributary area, guys, basically we would just be getting half of this span, kalahati niyan. Then kalahati din po ng span na to, that is half of this span. And then for the vertical part, that is half of this span here, and half of this span. Okay? So basically, this is the tributary area. Okay? So let me just erase that. And basically, this is the tributary area of column E. Okay, so if you are now wondering, so hindi po ba may one-way and two-way distribution? Why is it the case that this is only rectangle? Okay, so basically po, guys, again, for the slabs at the bottom part, for the slab at the bottom parts, again, both of these are one-way distribution. So basically, this is now its distribution. And for both beams, or for both slabs at the top, this and this, two-way po sila. And from that, we have trapezoids here, and you also have triangles here. Okay? And take note, guys, even though that those are the case, again nga po, if we are to go back to this particular slide, So if we would be going back here, yung bubuhatin po ng column na yan is yung kalahati po ng beam na yan, beam na to, beam na yan, and beam na naman na ito. Bakit po guys? So suppose that we have this particular area here. So for example guys na ito pong beam na to yung consider natin kunwari. Suppose that this is beam BE. Regardless of its support condition, suppose that this is fixed and this is fixed. And let's say that we have a triangular load here, which should be, what do you call this, symmetrical. If it is symmetrical, it means that for the support reactions, maghahati lang po sila. Okay? So let's say that this is R, this is also R. Maghahati lang po sila, and that is just half of the resultant. Okay? So same is true as with the other beams. So kung trapezoid man po yan, if it is perfectly symmetrical, if you would be getting the resultant, kunwari, yan po yung resultant na, assuming that it is exactly at the middle, pangit lang po yung drawing ko, for the reaction, that is the resultant over 2, resultant all over 2. Okay? So from that guys, regardless, yung maging area niya, ganito pa rin. Okay? So from that guys, this is half of 3.5, that is 1.75. And as for this one here, that is half of 4.5, that is 2.25. And then for this one here, this is half of 8 meters. And this here is just half of 4 meters. Okay, so proceeding po. So, again, we are to consider its area on the first floor. And if you could now imagine, if this is now the 2-story building, let's, for example, that this is the elevation if you are to view it at this side. So, for example, that this is the 2-story building, whereas this is now the column at the middle. And we have, again, let's say this first floor and this is second floor. And this is now our roof beams. So as for this particular column, which is column E, it would now carry the loads at this floor, and it would also carry the loads at this floor, which is for the roof beam. So from that, we would be reducing 2 times. I-reduce po natin yung sa roof beam, and we would also reduce for the second floor beam. Okay? So from that, let me erase everything once again. So, unahin po muna siguro natin yung sa second floor beam. So, for the reduction, reduction for second floor beams for that particular column. Again, for the area of the column or the tributary area, it is this area. So, this is 8 meters or 4 meters plus 4 meters. And this here is 2.25 meters plus 1.75 meters, or half of these dimensions respectively. So, this is 8 meters here if you would be adding 4 meters and 4 meters. And for 2.25 plus 1.75, so 2.25 plus plus 1.75. 4 meters din po ito. So this here is 4 meters. So basically 4 times 8. Okay? 4 times 8. This is, anong sagot doon? 4 times 8. 32. Okay? So this is now 32 square meters. And as you can see that it is greater than, mas malaki po siya sa 15. And from that, we could now solve for the reduction rate. Okay? So for the reduction, R, that is equal to, so erase ko na, medyo makalat po. So erase ko na to. So R is now equal to 0.08 times 32 minus 15. And the value for R would now be equal to, so 0.08 times 32 minus 15. Answer 1.36%. So again, this is for the floors, okay? So R is equal to 0.08 times 32 minus 15 for the flooring. And for the value of R, for the roofing, so R times what is the tributary area for the column considering the roof beams. It was stated earlier that the plan for the roof beams would be symmetrical, or sorry, not symmetrical, would be the same as with the layout of the floor beams. So dito po nakalagay. So, asa ba yun? If the roof beams have the same layout as with the given structural framing plan, ibig sabihin ganito din daw po. Okay? And it was stated here that it is rather flat. Ano pong kinalaman yan? So, in here. So, etong R po kasi na to guys, yung 8 na ginamit natin kanina, 0.08, that is for flooring. Okay? And for the value of R for the roof beams, it is actually located here. Nandito daw po guys sa babang ito. So as you can see that for this particular column, teka lang, lagyan natin. So ito po yung pagbabasihan natin ngayon. Okay? So yan na po yung value ng R. And since it is considered as flat, so sinabi naman po kanina flat, ibig sabihin its slope is equal to 0. We would now be making use of this R. And coincidentally speaking, it is still 0.08. Okay? So as you can see in this slide. So 0.08 pa rin po yung gagamitin natin. Kaso I just want to remind you na nagkataon lang na parehas po na 0.08. Okay, so times 32 minus 15. Bakit 32 pa rin? Kasi nga same po sila ng layout. And from that, we would be arriving at the exact same value. Okay? So this is for roof. Nagkataon po na parehas po sila. However guys, yung live load po, so for the live load for the floor, lagyan ko dito, live load for second floor, 1.9 po yan. But for the live load at the roof, going back to this table, so the live load that we will be using here, pagbabasan po natin is method 2. If this is method 2, uniform load na gagamitin natin nandito, and that with that, 1 kilopascal lang yung gagamitin natin. So from that guys, the roof live load is 1.0 kilopascal. Okay? So for that po, i-reduce lang po natin ng 1.36% yung live load ng roof, pati live load ng floor. Pero alamin po muna natin if pasok po sila sa Rmax. Okay? So, looking here at this location po, yung bandang taas, di ba meron po tayong provision dyan. Okay, so for the max, Rmax, since this column will now be supporting loads from different floors, in that case, yung roof beam pati yung second floor, mapupunta sa first column. From that guys, for our Rmax, ito po siya, 60%. Kasi hindi na po siya pwede dito because this is only for one floor. So again, this is not the case. But for this formula here, yung nasolve po natin kanina, so yung nasolve po natin earlier na Rmax dito, 77.81, yan po yung para sa, or maybe, sige, lagi ko na lang siguro dito. For yung Rmax na nandito, yung Rmax, or better yet, dito ko na lalagay, Rmax, 23.1 times 1 plus D all over L. So for flooring, di ba yung dead load natin 4.5? Tapos yung L natin dito, this is 1.9. Yung sagot natin dyan was 77%. Okay? So again, this is only for the floors. But what about for the roof beam? So yung Rmax ng roof, this is now equal to, so 23.1 times 1 plus D all over L. Kaso yung D naman natin ngayon guys, yung D, nakalagay dito yung dead load daw sa roof, 1.1. Tapos yung live load sa roof, napag-usapan natin kanina, this is now 1.0. So from that, this is now equal to 23.1 times 1 plus 1 all over, 1.1 all over 1. So from that, the maximum for the roof is 48.51. Okay? And as you can see, pasok sila. This is less than 77% and 60%. Itong 60% na to. And for this, mas mababa din po siya sa 60%, pati yung sa 40% na nasa calculator ko ngayon. Okay? So from that, yan na po yung gagamitin natin na reduction factor. Okay? So erase ko lang. So 1.36, tandaan ko lang. Again, the value for R for both, 1.36%. So 1.36%. So for the floor live load, yung sa para sa floor po, that is now equal to 1.9 times, ay hindi pala 1.9. Yung reduction, ay ilan tama pala? 1.9 times 1 minus 1.36 all over 100. So from that, the live load that we will be making use, we will be using here is, so 1.9, 1.9 times 1 minus 1.36 all over 100. So, oops, sorry, minus pala. 1 minus 1.36 all over 100. Yun na, parang walang kwenta na naman, 1.87 kilopascal. This is already the reduced live load as per NSCP 2015. And for the roof live load, that is equal to 1 times 1 minus 1.36 all over 100. Again, as a reminder, this one here, yan po yung according to NSCP kanina for roof live load. Okay? And from that, LR is now equal to, palitan ko lang to ng 1. So this 0.9864. Okay. So again, I just want to disclaim that if you would be making use of the Uniform Building Code, hindi po ganyan kalilit yung reduction. As you can see, parang walang kwentang nag-reduce ka pa. Basically, this is still 1 kilopascal. And basically, this is still 1.9. Parang walang epekto, no? So, with that guys, so nasa next video naman po yung explanation, pero kung titignan nyo nga po, parang wala siyang kwenta. And if you would now be comparing it with UBC, mag-iiba na po yung result and mas mararamdaman na po yung difference ng unreduced live load and reduced live load. So I'm not sure, maybe baka may ano lang po, baka may typo lang po siguro during the publication of NSCP 2015 na hindi po na-take into consideration yung difference po between metric and English units from UBC. So stay tuned for the next video po.